It's a subfield of machine learning corresponding to learning several levels of representation, which is a hierarchy. And higher level concepts are derived from lower levels, and same lower level concepts can be used to define higher level concepts. And the beauty of this is done in an automated manner without a manual feature definition and manual engineering of the features to represent the unstructured data. And that is the reason why today we have all those AI applications which are able to deal with text, speech, image, video as first class objects and really bypassing the manual, heroic feature engineering step. That's why today we're able to build vision systems of the scale where we're talking about industrial level detection of cancer, industrial level detection of driverless, whatever is coming in the way of driverless cars to detect. Same way you're able to detect things like constellations and their movement and special characterization. Think about the revolution this has brought about. This has brought AI to the mainstream. With this one technology of deep learning, which was what was doing was exactly what machine learning is doing. Machine learning is also doing classification, is doing regression, is doing clustering. But here we're doing clustering of images, we're doing classification of images, we're doing regression of images. But unlike machine learning, which is only dependent on X variables all interpreted by humans, but now we have an automated feature extraction. And that is reflected across, you can think about several examples. I gave you this example already, right? See this example. At the lower level, it looks at some edges, then combine that, it looks at some coordinates of that. Then higher level will be more detailed about a specific kind of a card. Depending upon level of layers, you form abstractions. One described using the next layer. One described using the next layer. One described the next layer. But that is a secret sauce of why we are seeing deep learning systems at the center of every AI system of today. All the applications I showed you, right? Detection of diseases. I told you examples of creation of music. I gave you examples of driverless trucks. I gave you detection of constellations. You saw that? Then we saw examples of human aids, right? You say something text, it will detect and automatically help where to go. So example after example. All of that dealing with unstructured data is possible because of this revolutionary technology, which is avoiding the main pitfall of conventional machine learning, which is feature engineering. Manual feature engineering is avoided by application of a deep learning technology which can automatically extract features but still do the same machine learning task. What is the machine learning task? It can be unsupervised or supervised or reinforcement. But those problems don't change. You may either do a classification or you may do a regression or you may do a clustering or association. But the data now can be unstructured also. Earlier when we were doing machine learning, we were talking about creation of proper X and Y like this, right? So that is why deep learning is so practically useful and studied in several AI domains because of the reason by which unstructured data has become first-class citizen just like structured data. Does it sound that it is exciting as compared to machine learning? It's still machine learning. It's a subset because you're still doing classification. You're still doing probably a clustering or still doing probably some regression depending on the use case. For example, if I have to predict what is going to be my next word based on all the types which I have typed, it's a regression algorithm for text. So you need to understand that the main role of deep learning subset of machine learning is to eliminate this concept of manual feature engineering and there onwards replacing that with something like an automated hierarchy of concepts, which is what we call as feature extraction automatically from an unstructured data. So, what is the properties? There are multiple layers between the input and the final output. It could be class, it could be actual value. Input can be image, piece of data, speech, video frame. Final layer is really typically a class, something like car type, specific time, specific character. Intermediate layers are automatically generated. Means, and each subsequent layer combines features of lower level to form a higher level feature. Lowermost layer is a very granular feature closer to input. The outermost layer will be one closest to the output. Suppose you're discovering type of malignancy, tumor which is malignant to that, it will be closer to a malignant tumor or a benign tumor. Or if you want to describe type of car, it will say this type of car is, or let's take face. The lowermost level, it just detect edges. Then it may detect some curves. Then it may say, I'm detecting nose, or I'm detecting lip, or I'm detecting eye. Then combine that, you get probably a frame of a face. Then it may detect face with actual orientation. So think about face also as a hierarchy of concepts detected from a lot of human faces fed to the deep learning model. So does that convince you that deep learning today is nothing but machine learning in a specialized form with these characteristics? One, it's highly applicable for unstructured data. Second, it is applicable for eliminating manual feature engineering. Third, it is still machine learning, one of the machine learning problems, classification, regression, clustering. Fourth, it allows us to bring unstructured data as first-class citizens, just like we deal with a structured data. And that is what we're talking about studying in this semester. We'll be looking at different architectures for deep learning, which are all doing similar stuff, extracting features from unstructured data. And most of them, let me tell you, are internally representing structures which are very close to how a human part of brain, how human brain will function. And that is why we're calling deep learning as something which is mimicking human brain-like structure. And with that, we stop my first lecture here. Tomorrow we'll go into the first architecture, which is responsible for how this concept came up. It's very old, 40 plus years old concept. It's not like it's a recent concept. It's invented in the 50s, in fact. One of the first inventions in AI was the concept of neural network. So I'll take any questions, couple of questions before we start today.
So what determines how granular is the first input?
Again, the question, it's a retrospective introspection, alright? It is representing these hierarchies, but do I know how granular it is? It's a bit of a black box. The levels actually depends upon how many levels of the network you are asking it to model. Because you may ask it to model with 5 layers, you may ask it to model with 7 layers, some with 10 features in the first, second layer is 100. So in fact, tomorrow after the first lecture on neural network, you'll start doing an assignment, which will be based on how you build a multi-layer perceptron with your own feedback, what structure of network you'll give based on detecting digits. So each one will be different. So if I give you an answer, then he may come back and add one more layer. Maybe it is a finer edge at the first layer, then second finer edge at the third. So it's purely a detection based on how many layers you're providing for that abstraction.
What about the computation time? Is it like this takes?
This takes long. So two caveats. It is more time taking than machine learning. Second, for it to work accurately, you need 100 times more data than machine learning. So if you're doing with 100 images, here better work with at least 1,000, 10,000 images. You may not do that in your lab, but may try with reasonable structure of lab. But think about that, the larger the number of data items, deep learning, the better it is. In fact, there's a curve which says that, which is very interesting, which says, it's okay, don't worry. So what it says is, if I were to do machine learning with data, it will peak out like this and stop at the level of accuracy. But if you want to get more accuracy with more data, you have to do with deep learning, it will go like this. That means it's able to exploit more data to get better models, better fitting models. So deep learning is preferred whenever you have large amount of data. And second thing is, whenever you do deep learning, you better make sure that you have good amount of data. Any other question?
So deep learning only, it is different in a way that you have this
feature engineering is removed. Like,
Exactly. It is
so it has additional algorithms that remove.
exactly. That's all. It is one kind of structure, but still does classification. You'll still do a regression depending on your problem. Okay? So see you tomorrow again, 10 o'clock I think. Same class. We'll start with the first architecture, which is the multi-layer perceptron. We'll first do some very basic history of how it was invented, what is it, why it went into 20-year love. Before it was, we started as a field. It was a major winter in the area of not 20, 30 years.